Alright, problem number 8, similar but not quite as straightforward. The force of acceleration due to gravity on Mars is, it says 3.711. We should make that a negative 3.711. Hopefully your sheet says that by this point. But the force of acceleration due to gravity on Mars is negative 3.711 meters per second squared, and we want to know with what initial velocity must an object be thrust upward from ground level with in order to reach a maximum height of 600 meters. So we're going to take our acceleration equation, a of t equals negative 3.711, and we're going to integrate that to get velocity. So we're going to get v of t equals negative 3.711 t plus v naught, our initial velocity. This time we will have an initial velocity. We're not dropping an object. It needs to start with some positive velocity that's going to propel the object upwards. So we get that equation. And now let's get our height function, h of t. It will equal t squared, and then we'll need to do 3.711 divided by 2. That's going to get us negative 1.855, so negative 1 point running out of room. Move that, and let's move that back. Whoops, negative. That's where we had it. Okay. Negative 1.855 is half of 3.711. Roughly. There's another 5 there. Well, okay, whatever. Let's just use it, and we'll be exact now. Okay. T squared plus v naught t plus our initial height, which is 0 because we're launching it from ground level. Now, what do we know? We know that we're going to reach a maximum height of 600. So let's plug that in. We'll get 600 equals negative 1.855 t squared plus v naught t. And what else do we know? Well, we don't know what time it takes to get to 600 meters, but we do know that at that time the velocity will be 0. So we can set our velocity equation equal to 0 and get negative 3.711 t plus v naught. So I'm going to solve that equation for v naught and get a positive 3.711 t equals v naught. And now I'm going to take that and substitute that v naught in to that v naught right there. So I'm going to get the equation then, 600 equals negative 1.8555 t squared plus, instead of v naught, I'm going to write 3.711 t. So 3.711 t, but then that's being multiplied by that t, so we'll get a t squared. Well, simplify, 600 equals negative 1.8555 t squared plus 3.711 t squared is 1.8555 t squared, because we know that's half of 3.711. That's how we got it. So we need to take 600 and we need to divide it by 1.8555, and we need to take the square root of all of that, and that will tell us our time it takes. So let's find our time. Doing so will give you roughly 17.982 with a little bit of rounding. But again, I'm just going to write that down. Let's give our little approximate symbols there. I'm just going to write that down for now, and then I'm going to use that exact value when I calculate it, because what do we want to know? We want to know the initial velocity. Well, we have the equation right there for the initial velocity, so we need to take our t value and multiply it by 3.711. So 3.711 times our time, 17.982, will equal v naught, which will get you a velocity of roughly 66.732 meters per second. And we're done.